In a standard concealed rafter roof design, how exactly should the internal vapor barrier seamlessly connect to the wall? How do you handle complex cavity brick wall eaves detail? Welcome back to Notes Architecture. Today we are going to break down a very classic and highly challenging eaves detail. Look closely at this drawing. It integrates advanced constructions we've discussed before, the extremely rigorous pre-laid airtight strip, and the exterior-facing brick cavity wall. Unlike our previous video, the interior timber is not exposed this time. Instead, it uses a standard concealed ceiling approach. Don't be intimidated by the complex lines. But in reality, as long as you grasp the true assembly logic of building materials, even the most complex detail is just a step-by-step process of building blocks. Grab your pen and paper. Today is the ultimate test of our detailing logic. Step 1. Establishing the main load-bearing skeleton. First, draw the vertical load-bearing inner wall. To connect the roof more robustly, a reinforced concrete ring beam is set at the top of the wall. Next is an extremely ingenious step. Before placing the timber wall plate, a pre-laid vapor barrier strip must be positioned on the surface of the concrete ring beam, and then the timber beam is pressed down and secured. After that, the slanted rafters rest on the timber beam. Why do we pre-lay the red line under the timber beam? Because the junction between the timber beam and the wall is the weakest point for airtightness. Pre-laying, it leaves the most important interface for us to perfectly seal the airtight layer indoors later on. Step 2. Establishing continuous insulation and outer waterproofing. We fill the spaces between the rafters with thick roof insulation. Simultaneously, we attach wall insulation to the outside of the load-bearing wall. The two meet perfectly on the outside of the timber beam, completely cutting off any thermal bridge. Immediately after, we lay a layer of exterior structural timber sheathing on top of the rafters, making it easier to then lay the outer waterproofing red line, the breathable underlayment. This membrane runs down the slope, and its end overlaps onto a metal flashing, precisely guiding water droplets into the outer gutter. Step 3. Perfecting the roof and ventilation system. We install counterbattens over the waterproofing membrane to form the crucial roof ventilation cavity. To avoid getting the direction of the counterbattens wrong, you just need to remember that the direction of the counterbattens is always the same as the roof's slope. This is exactly the path of cold air circulation entering the roof through this gap at the front of the eaves. Then we horizontally nail the roof battens and finally arrange the roof tiles. You can also notice this metal bracket on the roof. It is very common in cold winter regions, and its purpose is to act as a snow guard. At this point, the entire roof system has achieved ultimate thermal insulation, rainproofing, and breathability. Step 4. Returning indoors to complete the most critical closure of the airtight layer. Because this is a concealed rafter approach, our internal red line, the vapor barrier, is installed below the rafters. This membrane runs all the way down along the underside of the timber skeleton. When it reaches the corner, it's time for magic. We simply use professional tape to perfectly seal this main vapor barrier with the membrane we pre-laid under the timber beam in step 1. This red line elegantly bypasses the timber structure, blocking all indoor moisture from the insulation layer. Finally, we install the interior ceiling below the red line. This detail doesn't show the installation of a service void. In fact, you just need to fix a layer of battens, usually 4 centimeters thick, below the vapor barrier, and finally install the ceiling onto it. Within this 4 centimeter gap, you can route electrical wires and such. Friends who watched the previous episode should also remember this. Step 5. The final step, completing the facade system. On the outside of the wall insulation, we leave a ventilation gap to keep the wall dry. By embedding stainless steel cavity wall ties, we firmly hold the gorgeous outermost facing brickwork. The brick wall is built all the way up until it meets perfectly with the eaves soffit board. And with that, this advanced detail drawing integrating a concealed ceiling, a cavity brick wall, and a pre-laid airtight strip is completely finished. Don't just memorize lines. As long as you follow the assembly logic of the materials, everything will make perfect sense. If you found today's detail notes helpful, don't forget to like, save, and subscribe to Notes Architecture. Every Monday, I will use actual construction details to break down the most confusing construction knowledge. Let's level up our detailing skills together. See you next time.